A crow is watching you right now. Not just looking, watching. It has memorized your face. It knows your schedule. It knows what you threw at it last Tuesday. And it has told its friends about you. You think you're smarter than a bird. You're probably wrong. Today, we're going to prove it. The brain. Let's start with the brain. A crow's brain is tiny, about the size of a walnut. But here's the thing that changes everything. The part of the brain responsible for intelligence, the part that handles planning, problem-solving, and self-awareness, in crows, that region is proportionally larger relative to body size than in almost any other animal, including most mammals. When scientists measure something called the encephalization quotient, basically how big your brain is compared to your body, crows score higher than dogs, cats, and many primates. The crow's intelligence doesn't live in brain size, it lives in brain efficiency, and that efficiency produces something remarkable: face recognition. In 2008, a scientist at the University of Washington ran one of the most unsettling experiments in animal cognition history. Researchers wear specific masks while trapping and banding crows on the university campus. The crows were annoyed. Then the masks were put away. Months later, in some cases years later, researchers wearing those exact masks again were dive-bombed, followed, and scolded by crows across the entire campus. Crows they had never even met. The crows had passed the information about the dangerous face to their offspring, their flock, their community. Think about what that means. A crow saw a face once, told its children, and those children remembered a face they had never personally seen. Tool use. Now let's talk about tools. For most of human history, we thought tool use was what separated us from every other animal. We discovered chimps using sticks. Fine, we said. But then we discovered crows. New Caledonian crows don't just use tools, they manufacture them. They select specific twigs, strip the leaves off, bend the end into a hook, and use that hook to extract insects from tree bark. They test the tool before using it. If it breaks, they repair it. They carry their tools with them to use again later. This isn't trial and error. This is engineering, and it gets stranger. Mirror test and self-awareness. Here's the test that separates the truly intelligent from the rest. The mirror test. You put a mark on an animal while they're asleep, somewhere they can only see with a mirror. You show them a mirror. Most animals don't understand what they're looking at. They think it's another animal. They bark at it, ignore it, attack it. But a small number of species immediately understand. They touch the mark on their own body. They investigate themselves. They understand, that is me. Humans pass this test at around 18 months. Great apes pass it. Dolphins pass it. Elephants pass it. And crows pass it. Grudges and gifts. Here is where crows go from impressive to genuinely unsettling. Crows hold grudges. Real, long-term, multi-generational grudges. If you mess with a crow, trap it, scare it, harm it, it will remember you. It will follow you. It will recruit other crows to harass you. And it will do this for years. There are documented cases of crows targeting specific humans for harassment that lasted over a decade. But here is the other side. Crows also give gifts to humans who are kind to them. A girl in Seattle who regularly fed crows started finding small objects left at her feeding spot. A broken earring, a small piece of blue sea glass, a tiny rusted screw. The crows were saying thank you in the only language they have for it: future planning. Most animals live in the present. They respond to what's happening now. Hunger now, find food now. Danger now, run now. Planning for the future requires something called episodic memory, the ability to mentally time travel, to remember a specific past event and project it into the future. For a long time, scientists believed only humans had this ability. Then they tested crows. Western scrub jays, a type of crow, were given the ability to store food in two different rooms. In one room, they were always given enough breakfast. In the other room, they were always given no breakfast. The next evening, the jays began storing far more food in the no-breakfast room. They were planning for their own future hunger. They weren't hungry, but they anticipated being hungry, and they prepared. Problem-solving. In Japan, crows discovered something extraordinary. They learned to drop walnuts in front of cars at traffic lights to crack them open. They wait for the traffic light to turn red. They fly down and place the nut on the road. They fly back. The car runs over the nut and cracks it. When the light turns red again, they fly down and eat the walnut. They are using 3,000-pound metal machines as nut nutcrackers. They understand traffic lights. They understand vehicle patterns. And they do this systematically in multiple cities, having taught each other how it works. One crow figured this out, and the rest learned from watching. Crow language. Crows don't just call, they communicate. Researchers have identified dozens of distinct crow vocalizations, each with specific meaning. There are calls for different types of predators, different alarm calls for threats in the air versus threats on the ground, calls that mean come here, calls that mean stay away, calls that signal food, calls that signal danger at a specific location. Crows in different regions have different dialects. A crow from one city sounds different from a crow in another, like accents, like regional languages. They also use syntax. The order of sounds changes the meaning. This is not random noise. This is language, not human language, but a structured, symbolic, learnable communication system that varies by region, changes over generations, and carries meaning. Crow funerals and death. This is one of the most controversial and compelling behaviors scientists have observed in crows. When a crow dies, other crows gather. They make specific vocalizations, not heard in other contexts. They appear to investigate the body. They avoid that location for days afterward. Researchers believe this serves two functions. First, social bonding. The community processes the loss together. Second, and more remarkably, information gathering. The crows appear to be learning from death. If a crow died in a dangerous location, the flock avoids it. If a crow was killed by a predator, the flock becomes more vigilant. They are extracting lessons from mortality. They are teaching each other how not to die. Deception and strategy. Crows lie deliberately, strategically. When a crow finds a large cache of food, it will pretend to hide it in one place while a rival crow watches, then sneak away and actually hide it somewhere else entirely. They will even perform elaborate fake-outs, burying empty shells to mislead watchers. They do this more when they believe they are being watched by a smart rival, one who they know understands deception. This requires extraordinary cognitive architecture. To deceive effectively, you must understand what the other individual believes, predict their behavior based on that belief, and craft an action that exploits the gap between their belief and reality. This is called Machiavellian intelligence. It was named after a human political philosopher, and crows have it. What crows teach us. So what does all of this mean? It means that intelligence is not a human invention. It is a solution. Evolution independently arrived at high intelligence in at least two completely separate branches of the animal kingdom. Mammals and birds, crows and humans share no common intelligent ancestor. We evolved our intelligence separately, yet we arrived at the same tools: planning, memory, deception, social learning, language, grief. This is called convergent evolution, and it suggests that intelligence, the ability to model the world, predict outcomes, manipulate information, is so useful for survival that nature invented it twice, maybe more. Living with crows. Crows have chosen to live near us, not because we forced them, because they chose us. Cities are good for crows. We produce waste, they eat it. We build structures, they nest in them. We create artificial light, they use it to stay safe. But something more interesting is happening. Crows have begun adapting to human culture at a speed that is genuinely startling. They have learned to use pedestrian crossings. They have learned to avoid certain vehicles while tolerating others. They have learned to distinguish between uniformed workers, who they generally ignore, and researchers with equipment, who they harass. They are modeling human society, and they are finding ways to exploit it. So the next time you see a crow sitting on a wire watching you, know this. It knows your face. It may know your schedule. It remembers the last time someone hurt one of its family members. It has a language. It grieves. It plans. It plays. It deceives. It makes tools. It teaches its children. And somewhere in that small walnut-sized brain is an intelligence that evolution built completely independently of ours and brought to almost the same destination. We are not the only ones who think on this planet. We are just the ones who spent the longest time assuming we were. Next video, we're going even deeper into the animal kingdom. Creatures so alien that scientists genuinely debate whether they are conscious and what their answer means for us. Subscribe. I'll see you there.